Welcome back. In today's video, this is a continuation of our C tutorial. Today we're looking at variables in C. So C variables. Variables are containers for storing data values like numbers and characters. What does this mean? Let me do an illustration so that you guys can understand. So this is the random access memory on your computer, the computer RAM, which we call the primary memory on your computer. The primary memory is used to store program instructions. Okay, so it's easily accessible to the computer. It's a little bit faster than secondary memory, so the RAM is important. And so this RAM has got a size on your computer. Usually we have 2 GB RAM, 2 GB, we have 4 GB, we have 8 GB RAMs, we have 16 GB RAMs, we have 32 GB RAMs, etc., etc. So the bigger the size, the better the RAM. All right, so with this in mind, these are memory locations, this black stuff that is here. So I have abstracted this to this illustration, this diagram here on the right of your screen. So we are focusing on this thing. So this is now a RAM. But of course, we have abstracted it from this RAM, which is electronics, to something that is an illustration. This is what we're going to use to talk about variables today. And so on your computer, you have what you call memory location. This memory location is obviously in your RAM. So you have these are memory locations, these compartments here, they are memory locations. This is where you want to store your data. Obviously, memory is there for you to store data. It could be your documents, it could be your movie, some kind of data that you want to store on your computer. And so this RAM can help you to do that. And so when you declare a variable, or when you create a variable in any programming language, you are accessing these memory locations over here. So let me number these because they have addresses. We call these memory addresses, right? They are locations on your computer, memory locations. And so let's assume this is address 0 and the last one is address maybe 10. The computer uses a different numbering system. It uses hexadecimal, but for the purpose of illustration and simplicity, let's just say this is address 0 and this is address 10, and the others 1, 2, 3, 4 up to 10. And so when you create a variable, when you declare, because when you are creating a variable, you declare a variable and then you assign it a value. When you declare a variable, you are setting aside space on this RAM. You are telling the computer, okay, computer, can you please set aside this specific amount of memory for me. In programming, we name these locations. So let's say we want to call this num. So we are telling the computer that, okay, reserve space for me called num. Give it a name called num. And the computer, what the computer will do is it will look for an empty slot on your memory. Of course, not all of it is empty. Some of it is being used by your computer for other programs. And so it will look for an empty slot, and then it will then assign that particular slot. It will set it aside. What that means is it's not going to allocate it for any other purposes. You have reserved this particular space for whatever you want to do. And so these are what we call variables. So in C, these variables, they have types, because in C we have different data types. So why is it like that? We are primarily focusing on data when we're talking about computers. And so let's say we have whole numbers. We call these integers. They require a different amount of space than when maybe you want to store maybe a character, a single character, an A, a B, or a C. Okay, so the space required by integers on current architectures like 64 bits, you usually require 4 bytes of space. and for a character you need just 1 byte of space. So it's important for you when you create a variable in C to tell the computer what type of data you are storing at that particular location. So the way we create variables is we have to specify the type and then the variable name, and then we can assign it a value. So I'm going to vi our prog and then open this up. So last time we were talking about comments, and so today we're talking about variables. So what I'm going to do is I'm going to remove this line here, and let me see. Okay, and then here usually it's recommended that you declare variables or you create your variables and put them at the top at the beginning of your program. Yeah, so here we're going to create a variable. So the first variable that I'm going to create is an int variable. These are data types. These are what we call primitive data types in C. C already know about these data types. So int, and then let's call this. So I said the data type, and then the name of the variable, I want to call it num, and then we can assign this any value. So let's say we can assign it 80 like that, and then we put that semicolon. So this line here, this is a variable. We have successfully created a variable in C. We can approach this in 2 steps. We can declare and then assign a value. So we could have done the same by, let's create another variable. Let's call it num1, and you can do this in C. This line here, we have just declared a variable. We did not assign it a value. We can then go on later on in our program. We can then call this num1 and then assign it maybe a value of 100. This is also allowed. So you can do it in 2 steps, declaration and then assignment, or you can just declare and assign in 1 line like this. This is how you create your variables in C. So let's look at this structure over here. So we have int num equal 80. So this is not an equal sign. In programming, we call this an assignment operator. The equal sign is an assignment operator. So what is happening is we are taking the value which is on the right side, which is 80, and we are placing it inside the container called num. Similar with 100, we are taking the 100 and then we are putting it inside this container called num1. So this is what I want you to think of when you look at this. So variables start from the right. You say take 80, put it inside num, or take 100 and put it inside num1. So these are containers. Num and num1 are containers. And then you can then access these memory locations, because we said if you're doing this, you are setting aside some kind of space in memory. You then assign a value to that particular location. And so if you want to then use that value, you can just refer to this name here. So that location is given this particular name, and the computer will always remember this particular name, and it will take you to that particular address each time you want to access this value. You can also reassign this value, this num. You can also reassign it later on. That's why it's called a variable, because the value in there can change anytime. You can change this num from 80 to some other value. All right, let's see how we can print this. Printing in C is kind of different from other programming languages like Python. In Python, we can print the variable directly. We can say num here and print, that's okay. But for C, it's not the case. We shall see this. Let me try and print and num1 as well and see what happens. So I'm going to exit this and then recompile. So we said we can GCC this, and then we can GCC our prog .c, and then we can output it as prog. And let's see what happened here. So it's giving me some kind of a warning, because what I'm trying to do here. The way the printf function works is that you have to provide some kind of a format specifier, and then you can print the variable. Let's try and run it, ignoring that warning. Let me see. So we are running our prog here. Try and run that. You can see there is a segmentation fault. It's not allowed. Segmentation fault simply means you're trying to access memory locations that you are not supposed to be accessing. So let's get back to our program and fix that. So here what we're supposed to do is, in C, if you want to print an integer, for instance, you have to use format specifiers %d /n, and then this. Our variable has got an integer, so %d will represent that int. And same with this line here, we need to do the same. Okay, and then we recompile our program. And so now you see there are no warnings now. You know, if you compile a program and it's just silent like this, it means there are no issues with your program. So now I'm going to run that. If you run that, you can see we printed the 80, the 100, and then hello world, and also I'm also here. Yeah, so this is how you do it. If you want to print out a value, you have to use format specifiers. These are format specifiers. The %d is a format specifier for integers, and so this is what you have to do. D. These are decimal numbers. I'm sure decimal number. %d. You know, you might argue and say, where am I getting this from? When they created this printf, they specified that if you want to print a variable, you have to use format specifiers. It's not something that I'm just making out of my mind. All right, so we can see down here it says format specifiers. Format specifiers are used together with the printf function to tell the compiler what type of data the variable is storing. It is basically a placeholder for the variable value. So like I said, this %d is a placeholder for the value that is inside num. And so the way printf was created is that when you have a format specifier here, you have to pass in another argument to specify the value that you want to replace the %d or whatever. Strings, they are %s, characters %c, depending on the type of data that you want to print out. You have to specify the format specifier here. All right, so one more thing to note, when you are creating variables, this is important for you to note. All C variables must be identified with unique names. These unique names are called identifiers. So identifiers can be short names like X and Y, or more descriptive like age, sum, etc. These are general rules for naming your variables. Names can contain letters, digits, and underscores. So you are only restricted to letters, digits 0 to 9, A to Z, and then underscores. Names must begin with a letter or an underscore. No variable should begin with a number. Names are case sensitive, and so this means if you create a variable called my var with capital letter V, it's obviously going to be different from my var, which is all lowercase. Names cannot contain white spaces. You cannot put spaces in between the variable name, and you cannot also use these special characters like, you know, the exclamation mark, this pound or hash symbol, or the % sign, because they have different, you know, meanings in C, so you cannot use them in variable names. Reserved words such as int cannot be used as names, so you cannot use a variable, call it int here, say let's say int, you cannot do that because these are reserved names in C. All right, so I hope this is helpful. If you do have any questions, please leave them in the comment section. Do not forget to subscribe to the channel. I hope to see you in our next tutorial. For now, I'm out. Bye bye.